Okay, today we are working on lesson 31, adding integers and collecting like terms. Adding integers can be thought of adding on a thermometer, for instance. If it tells you that when you get up in the morning and the temperature is -4 degrees and the temperature rises by 10 degrees at noon, by noon, what would the temperature be at noon? Well, on a thermometer, it started at -4, and if you go up 10 degrees, you go up 4 degrees to get to 0, and then you go up 6 more degrees, so the temperature at noon would be 6 degrees. You can also model this on a number line, and so it said you started at -4, so you would draw a line from 0 to -4, and then it says you go up 10 degrees, so you need to go to the right or in the direction of positive numbers 10 degrees, and you end up at 6 degrees. Two ways to model. They are going to ask you to model on a number line, and so you need to make sure you are drawing your problems correctly until they tell you you don't have to draw them anymore. So if you had a +3 plus a -5, what would you do? You would start at 0 and draw your arrow to +3. Now it says go in the negative direction 5 steps. Well, you go 3 to get back to 0, and you would go 2 more, and you would end up at -2. What if they told you to add -5 plus -3? You would start at 0, you would go to -5, and they want you to go in the negative direction 3 more. You would end up at -8. So -5 plus -3 is -8. This one models +3 plus -5, and your answer is -2. So let's look at these 4 problems where we're not going to draw a number line, but try to figure it out. This says start at -6 and go 2 in the positive direction. Where would you end up? Well, you would end up at -4. This one says that you're supposed to start at +6 and then go 2 in the negative direction. Where would you end up? You would end up at +4. The next one says start at -6 and go 2 more in the negative direction. Where will you be? You will be at -8. And the final one says start at -6, move 6 steps in the positive direction, and where would you be? You would be at 0. And this is the sum of opposite numbers is 0. So they are also called, 6 and -6 are also called additive inverses of each other. So here are your rules for addition. If the 2 digits that you are adding have the same sign, you just add them and use that sign. If you have opposite signs, subtract the 2 numbers and use the sign of the number with the greatest absolute value. For instance, if you have 6 plus -12, the absolute value of 6 is 6. The absolute value of -12 is 12. Here is your larger absolute value. The sign of that number is negative, so your answer will be negative. So you subtract the 2 numbers, 12 minus 6, you get 6, but you found out that you need to use a negative, so your answer to that problem is -6. Okay, now we're talking about combining like terms, and we've used, they have to have the same last name. Well, first we have to define what is a term. Here are several examples of numbers and letters that are terms. 3y is a term. Notice you are multiplying those 2 numbers. W is a term. -w squared is a term. 3x squared y is 1 term. Even though there are a lot of factors in there, it is 1 term, and -2 is also a term. You need to know what a numerical coefficient is, and a lot of times it's just called the coefficient. It is a number in front of a variable. And here's what you have to remember. every variable has a coefficient. Every single one. Never put down that there is no coefficient. So if we look at 3x, the numerical coefficient is 3 because there is a 3 in front of the variable x. If we look at 4x squared y, your variables are x squared y. What is the numerical coefficient in front of it? -4. Well, let's look at w squared. Here's your variable. Where is your coefficient? Because I said every variable has a coefficient. Well, it's your identity. So there is a 1 in front of there, and you have to remember that. You don't usually put it in. If it helps you to put the 1 in front to remember that it is a numerical coefficient, go ahead and do that. What about -x cubed? Well, you can pick out the variable. It's x cubed. So what do you think the coefficient for that would be? Well, we just said if there's nothing there, it means really that there is 1, which is the identity. So in this case, it is -1. Once again, we're going to say like terms have identical variable parts. So let's look at this number, -5xy and yx. And I'm telling you that they are identical. Why? Because yx is xy because of the commutative property of multiplication. So they are like terms. What about 2xy and -5x squared y? They are not, because they're identical. Their variables are not identical. You have x and x squared. They are not the same. So they are not identical variable parts. Okay? So how would we add -5xy and yx? Well, first we would rewrite it to show that they are the same. And to start with, I might actually add in the numerical coefficient that's kind of hidden in that term. So we would say, what is -5 plus a +1? And that's -4. Your variables never change. Your last name stays the same. The variable part stays the same. All you do is change your numerical coefficients. So we're now going to look at this problem and try to combine like terms. When you combine like terms, this is an expression. You are not going to come out with an answer. The first thing we're going to do is use the commutative property of addition and get all the x terms together and all the number terms together. So I'm going to rewrite this as 3x minus x plus 2 plus 3. And I'm going to say I see 4 terms here. I see 3x, -x, 2, and 3. And which ones are like terms? Which ones have identical variable parts? Well, the 2 and the 3 are very easy to see that they are identical terms. This has an x, this has an x. They are also identical terms. So I can combine the triangles and the circles. We kind of did this last year. So 3x minus 1x is 2x. 2 plus 3 is 5. Your answer is 2x plus 5. You cannot combine that. These are two different families. You have a family with the variable last name and a family with no last name. So your answer is 2x plus 5. It's okay to have an answer just like that. How would you find perimeter? Well, this is a 3 up here. So you would say perimeter equals 2 times 3, which is the length, plus 2x, which is the width. And then you should say to yourself, this is the distributive property. So I'm going to use the distributive property and get 6 plus 4x, and that is my perimeter. So I'm going to put perimeter equals 6 plus 4x units. Normally, you would write 4x plus 6 because in algebra the variables come first. But either way would be fine for now. But if you get into the habit of writing it like this, you're going to be one step ahead. So this is a tricky lesson. You're going to need to practice it. It would be helpful for you to reread the lesson. Please do page 207, A through N, and we will go over those tomorrow. Thanks.